Hi, Math 1. We are all the way through the end of the chapter in terms of lessons 1.1 to 1.10. We are now reviewing. We've got two of these, and what I'm going to do is go through the I'm going through the even solutions so that you guys have a lot of extra help along the way as you're wrestling with these problems. So, our first section is going to be simplifying these like variable expressions using a combining like terms proof, distributive property, commutative property, substitution property. So the first thing you'll notice on number 2 is that there's no parentheses, so there is no distributive property. So you're down to two moves, I guess, that you can make along with the proof. So let's think. We want to get like terms side by side. So I see a 4xy, and I see a 7/12 xy. I also see a 1/2 yx, and it's minus. And instead of keeping it as yx, I'm going to use the commutative property of multiplication to say that y times x is the same as x times y. Which is true just informally thinking about it. Is 4 times 5 equal to 5 times 4? Yeah, 20 equals 20. And you could think about a bunch of different examples that would probably lead you to that conclusion. Anyway, I'm going to get the y's together as well. So negative 4/5 y and positive 1/6 y. So that's the rearranging property, commutative. Now this is the move where we should probably find common denominators and then add or subtract given whatever we have. So these three need a common denominator and these two need a common denominator. They don't all together need the same one. I just need the xy's to be the same and I need the y's to be the same for their little group. So if you think about 3, 12, and 2, 12 already divides 3. 12 divided by 3 is 4. 12 divided by 2 is 6. 12 divided by 12 is 1. That's the common denominator we want. So this over 12, this over 12, and this over 12. You compute that by saying 3 times what gives me 12? 4. Which means I got to multiply the top times 4 as well. 16 over 12. And we've got xy's here as well. xy, xy, xy. This one remains unchanged because the bottom remained unchanged. And then this one is going to be times 6 on the bottom times 6 on top. What is 16 plus 7 minus 6? Sixteen plus 7 is 23. Subtracting 6 is 17. So you have 17/12 xy. Over here, you need to find a common denominator between 5 and 6. 30 is that number. So negative something over 30 plus a different something over 30. So yeah, 5 times 6 gives me 30, so I got to do 4 times 6 on top. That'll be negative 24y. And then 6 times 5 gives me 30, so I got to take 1 times 5. Which gives me negative 24 plus 5. Opposite signs subtract. So you're taking 24 minus 5, which is 19 over 30y. And then since the bigger number is negative, when you did that, it's got to be a minus. So what I'm going to do is I'm going to take this negative of the 19 and call it subtraction between the two. You can do that. And this whole thing was substitution. All right, so that's what number 2 should look like. Number 4. Yeah, it's basically what we just did, except we don't have to do any of the calculations. Looks like from step given to step 1, or line 1, you got rid of the parentheses. There's no more parentheses, so you're not going to use the distributive property again. From here to there, let's see, same. These became negative 30. That's substitution when you do a calculation like that, and replace it with its value. All right. So where were we at? We went here. Now we're here. Looks like we have the same number of terms. So all we did was we rearranged it. 7m's now in the front of the pack. So the rearranging property is the commutative property. And then lastly, this was simplified from 7 plus 2m to 9m. All right, it's officially proven. All right, next we've got these kinds of proofs, order of operations. I'll do number 6 with you guys. What I would do is get that proof sheet handy so that you can reference it. And then if I make a move and you're not sure, pause the video and reference that sheet until you figure it out. I believe it was notes 1.7. All right, so to make a proof from scratch, my first move is going to be write the given. Inside the brackets, I'm going to do the exponents first. So 7 minus 4 divided by 36 times 9. Yeah. I had a thought, but I'm taking it back. All right. 3 squared equals 9. That's a sub. It doesn't include a 1 or a 0. It's got to be sub. Next, this is where a lot of people will make one of 2 mistakes. The first mistake is they'll try to go for 36 times 9. You shouldn't do that. You should do multiply or divide left to right. Second mistake they do is they say 4 divided by 36, they say that that's equal to 9. It is not equal to 9. 4 divided by 36 equals 4 over 36. Well short of 1. Divide the top by 4, 1. Divide the bottom by 4, you get 9. It's 1/9. 1/9 is not 9. So make sure that you are thinking in terms of fraction, fraction, fraction on this one. That's always a sub move when you deal with division like that. All right, 1/9 times 9 is equal to 1. They're inverses of each other. If you look at it in terms of 9 is the same as 9 over 1, right? And then they come out to be 1 at the end. So 1/9 times 9 is the same as 1/9 times 9 over 1, which is the same as 9 divided by 9, 1 over 1 equals 1. That's the multiplicative inverse if you check out your sheet of properties and you're still not quite sure about it. All right, next. These brackets just mean multiplication. So you're multiplying by the 7 to the right of it in this case. So it's really like this is what's going on. Minus 7 plus 4. So you got 1 times 7 became 7. Anything times 1 That's the mirror image of what you multiplied. It's the multiplicative identity. And now we have add or subtract from left to right. 7 minus 7 is 0. That's the additive inverse. And then lastly, the 0 plus 4. It's 4. That's what we were trying to prove. All right. And we finish up with the additive identity. Anything plus 0, or anything minus 0, or 0 plus anything, or 0 minus anything is the, can you guys see that? You can see that, is the additive identity. All right. Okay, so we got one of these deals. You're comparing root 41 to 70 over 11. And our task is to determine which number is bigger, and then we put a, let's sort of think of it as like, here's root 41, here's the box, here's 70 over 11. Is it greater than, less than, or, I mean, they're usually never equal to each other. So, there we go. Now, I'm not really doing anything with this number. It's kind of stuck in the mud. We can estimate that it is really, really close to, or it's between these two. Root 36 and root 49 are 6 and 7. All right? It's 6 point something. That's all we can really say about it right now. But we can turn 70 over 11 into a root by multiplying it by itself. So this is actually a really, I don't want to say simple calculation, but when you think about it, 70 times 70 is really just 2 zeros and then whatever 7 times 7 is, 4,900. If you have to stack it, here's what it looks like. 0 times 0 is 0. 0 times 7 is 0. Drop a 0. 7 times 0 is 0. 7 times 7 is 49. There's no decimals, so that is what it is. It's nice to have those shortcuts, especially on a test, right? So 11 times 11, if you've got that memorized, it's 121. Again, you could work it off to the side as well. You would take 4,900 divided by 121 to determine what sort of that decimal or mixed number is, and then compare it with 41. So I think 121 is going to go into 490 4 times, because 400 is kind of what's going on. So 4 times 1 is 4. 4 times 2 is 8. 4 times 1 is 4. Subtract the digits. 490 minus 484 is 6. Now here's the important part. If I drop a 0, I must now ask, how many times does 121 go into that number? 121 cannot go into that number. 0 times does 121 go into 60. So that's all the information we really need. We know that this is 40 point something, and this is 41. 41 is greater than 40 point something, which means root 41 is greater than 70 over 11. Now, there's an alternate way of working this out that a lot of you guys do, but it's kind of risky. So here's alt number, I think we're on number 8. Yeah, we're on number 8. Alt number 8. is where you take 70 divided by 11. 11 goes into 70 6 times. We got to put a 0.0. Subtract, you get 70 minus 66 is 4. Drop the 0. 11 goes into 40 3 times. 3 times 33 is... 3 times 11 is 33. Subtract 7. Drop another 0. 76. Oh yeah, the 11ths were the point, like the repeating 3, 6, 3, 6, 3, 6, 3, 6. Now the question is, all right, I now got to take 6.36 times itself. It seems like we're already doing more work than we had to over here. So I'm just saying, this isn't all peaches and cream. This is not my favorite use of, I would rather do this on example number 8. But anyway, if you multiply this out, and I'll do it quickly for time purposes, so 36, 21, 38, 0, 18, 10, 19, 0, 0, 36, 21, 38. 9. Okay, 2 digits here, 2 digits there, 1, 2, 3, 4. So move in 1, 2, 3, 4. 40.4496 is still less than 41. So that leads you to the correct answer as well.